In this section, we're going to be talking about rational functions. And rational functions are just functions that look like the quotient of two polynomials. So we can have a polynomial on the top and a polynomial on the bottom. One thing that we're going to talk about with rational functions is the domain. To find the domain, we're looking at any values that make the denominator equal to 0, and those values need to be excluded from the domain. The next thing we'll talk about with rational functions is finding the x-intercepts. To find the x-intercepts, we want to know where the function values are equal to 0. The only way that that can happen is if the numerator is equal to 0. So for these, we'll be looking at where the numerator is equal to 0, and that will give us our x-intercepts. We'll also be talking about vertical asymptotes. A vertical asymptote for a function creates a certain type of behavior in the graph. So first, we'll look at how to find where the vertical asymptotes are, and then we'll see what the behavior looks like on the graph. Most of the time, the vertical asymptotes are at the same values that we had to exclude from the domain. There's one exception to that, and that's if there's a value that makes both the numerator and the denominator 0, then instead of having an x-intercept there or a vertical asymptote there, we have a hole in the graph at that point. In this example, we're going to find the domain and the x-intercepts and the vertical asymptotes for the function. Let's start with the domain. For the domain, we're looking at what values need to be excluded, and those are values that would make the denominator equal to 0. And if we have a complicated denominator, what we can do is take our whole denominator and set it equal to 0 and then solve for x. Since this one is already in factored form, we can just take each factor and set it equal to 0 and solve for x. If we do that, we would get x equals -3 and also x equals 5 as solutions. These are the values that have to be excluded from the domain, because those are both values that would make our denominator equal to 0. If we want to write our domain in interval notation, we could think about a number line with these two values on it, and we want to do intervals on either sides of those two values. We'd have one that would go from -∞ up to -3, and then one that would go between the -3 and the +5, and then a third one that would go from 5 to infinity. This would be our domain. Now let's look for the x-intercepts. For these, we're looking at the numerator and setting that equal to 0. For this, we have x minus 1 equals 0. Where that's going to happen is at x equals 1. So our x-intercept is the point 1, 0. And just like we saw with our polynomial graphs, this means that the graph is going to cross or touch the x-axis there. And in fact, this is the only place that the graph can cross or touch the x-axis. The last thing we're going to talk about is the vertical asymptotes. Notice that when we found the values to be excluded from our domain, and we found the value for our x-intercept, these didn't match at all. What that means is that the two values we excluded from the domain are automatically where our vertical asymptotes are. I'm abbreviating vertical asymptote as VA. I'm going to have vertical asymptotes at x equals -3 and x equals 5. Since these are vertical lines, then to write the equations for these two, we actually have to include the x equals part. Our equations for our two vertical asymptotes are x equals -3 and x equals 5. Now let's take a look at what this means for the graph of the function. I have the function in my y equals menu, and notice how many extra parentheses I put in there. Since the numerator had two terms, I had to put parentheses around that. And since the denominator had two different factors, I also had to put an extra set of parentheses around that. Otherwise, my calculator would not be giving me the correct graph. All we want to look at for right now is what happens with our x-intercepts and our vertical asymptotes. We were supposed to have an x-intercept at the point 1, 0, so we just want to verify that. It looks like the graph is crossing the x-axis at that point. Let's verify that with a trace. So yes, there's an x-intercept there. Since that was the only x-intercept we have, that tells us that even though this looks like this graph is getting very close to the x-axis on the right end and the left end, that means it can't actually be touching or crossing the x-axis. This is the only place that that can happen. The other thing we can look at is the behavior close to our vertical asymptotes. We have one vertical asymptote at -3. On one side of that vertical line, the graph is going down, so we'd say the y values are going down to -infinity. On the other side, the values are going up to +infinity. That's the type of behavior that we see around a vertical asymptote. We also have a vertical asymptote at x equals 5, and even though the calculator is not doing a great job of graphing this, we're still seeing the same type of behavior. If we used our trace and went closer to that vertical asymptote at x equals 5, our y values would just keep going down. The closer we get to 5, the further down our y values are actually going to go. If I put in 4.99 for x, my y value is all the way down almost to -50. And the same thing on this side, only on this side they're going up towards +infinity. That's the type of behavior we expect around a vertical asymptote. Now let's look at another example. We're going to do the same three things for this one. Let's start with the domain. We want to know what values make our denominator equal to 0, and those are the values that we'll be excluding from our domain. I'm taking the denominator and setting it equal to 0, and I want to solve this for x. Notice that this is actually a quadratic equation because it has the x squared. We have lots of different methods to solve this. I'm going to do it by factoring because this is going to be easy to factor. I'm just factoring out an x, and that gives me two factors, x and x minus 3. If I take those two and set them equal to 0, I'm going to get two solutions for this, 0 and 3. That means those are the two numbers that need to be excluded from the domain. So for my domain, I could say x is not equal to 0 and x is not equal to 3, or I could write it in interval notation. For that, I would go from -infinity to 0, from 0 to 3, and from 3 to infinity. Now let's look at the x-intercepts. For this, I want to see what would make my numerator equal to 0. If I don't know what else to do, I would just take my numerator and set it equal to 0, and I want to solve this for x. Well, this equation, because it doesn't have any x's in it, and I have different numbers on the two sides, this equation has no solution. If your numerator is just a constant with no x's at all, then you're not going to have any x-intercepts. The graph of this function is never going to cross or touch the x-axis. Last of all, for our vertical asymptotes, I can just go back to the numbers we excluded from the domain, and those are both going to be the locations of my vertical asymptotes. So most of the time, finding the vertical asymptotes is going to be very easy if you've already looked at what the domain is. Now I'm going to graph this function and see what happens when I don't have any x-intercepts and when I have my two vertical asymptotes. This time, since I know there are no x-intercepts, I know that the graph isn't actually touching or crossing the x-axis on this end or on this end. And I can see for my two vertical asymptotes, the one is at x equals 0. That's the same as the y-axis. And I have that behavior on the two sides of that. As we get close to this vertical asymptote from the left, our function values are going up towards +infinity. As we come this way from the right, the values are going down towards -infinity. And for our other vertical asymptote at x equals 3, we've got the opposite thing happening. So as we come towards this from the left, our values are going down. As we come towards this from the right, our values are going up.